becomes a problem in evaluating a double integral. Then I needed to sketch where this region is and decide which type I want to go. All right? So this is the radius R, which is exactly what we discussed. Maybe to make my simple region, let's make this radius capital R. Okay? So this region, as we discussed a couple minutes ago, can be identified as both a y simple, x simple, and a polar coordinate system, right? But you can identify it as y and x simple regions. The formula is not going to be fertile to work with, right? You needed to find the antiderivative of minus r to r, and then minus square of r squared minus x squared, plus r squared minus x squared, then 1 dy dx. You can identify it as a y simple region where x is bounded by minus r and r. You have a lower function, square root of r squared minus x squared minus, and upper functions, square root of r squared minus y squared, minus x squared. And then you need to evaluate this whole thing to find the answer, right? You need to evaluate the whole thing to find the answer. However, we know we can also identify this disk as a polar rectangle, which has a simple form of r is bounded between 0 and capital R, and theta is bounded between 0 and 2 pi. Am I right? That's what we need to do. Which means evaluating the double integral. Oh, before I even evaluate this, what is the formula for the area? Pi r squared, right? That's the formula for the area of a disk. If you look at this double integral, it's pretty hard to imagine why you can get a pi in the end. So here, if I can identify it as a double integral in the polar coordinate system, it's going to be from 0 to 2 pi, from 0 to r, 1 multiplied by r dr d theta. All right? It becomes most trivial. So this guy is equal to from 0 to 2 pi. The antiderivative of r is half of r squared, evaluating from r equals 0 to r equals capital R dr d theta. So the inside is going to be from 0 to 2 pi, half of r squared. When r is equal to 0, you don't have anything. And then d theta. This thing has nothing to do with theta. The antiderivative is nothing but half of r squared, theta evaluating from theta equals 0 to theta equals 2 pi. Am I right? Theta equals 0, you don't have anything. When theta equals 2 pi, you're getting a pi r squared, which is absolutely amazing if you look at the power of polar coordinates, right? You can deal with regions in this form in a very, very easy way, right? So if you want to use the x and the y simple region, you can still do the following, okay? You can still try and see how you can end up with pi r squared. You can do that. You need to find the antiderivative of these kind of functions. It's not going to be easy, but there are formulas. But if you have this polar coordinate system too, you don't have to know anything, right? This thing is just so simple. You can immediately get the power, the area of the disk. So we are pretty much done about our discussion about double integrals, but we have one more type of region to introduce, which is so-called R simple region. Okay, but I want to leave that to next week. So the most important thing about the integrals, triple integral, double integral, is to practice. I urge you to go back and practice as many problems as possible. Okay.